we're still working with exponential equations, exponential functions. We're going to be, after tomorrow's quiz, we've got another maybe 3 or 4 lessons on them. Today we're going to be solving them. We're going to actually come up with single number answers. When we only have one variable in an equation, we can find out the number that would make that equation true. We can find the solution. So here we only have the x, and we need to solve for it. So taking a look at number 1, it's saying 3 to some power gives us 81. Exponents, remember, tell us how many times we multiply that 3 by itself, right? So think to yourself, how many times would you multiply 3 by itself to give you 81? 3 times. If it said 3 times x, then that would be the right answer.
I feel like it would be 4.
And you guys, most of you have calculators. If you don't have a calculator, grab one from the desk next to you. And I think it is 4.
Yeah.
I think 3 times 3 is 9. And then a third time gives you 27. And a fourth time. So let's go ahead and write that off to the side. Write down 3 to the 4th power equals 81. And my 8 and my 1 ended up way off. All right, so that's telling us what the x is, right? So since we filled in 4 in place of the x, we can say that x equals 4. Not a lot of work to be shown. I would like you to rewrite it with no letters in there, no variables. This next one, that's not quite gonna work. It would, multiplying it to the 1/2 power, or raising it to 1/2 power, would make it smaller, but it wouldn't make it all that much smaller. It would still be greater than 1. It turns it into a number that's less than 1. And so before, when we were dealing with negative exponents, remember how to get rid of a negative exponent, you would flip what it's equal to? So you would start with a 64 and it would turn into 1/64th. And so if we see 1/64th already, we know it's going to have to be a negative number. X is going to have to be a negative number. So start off giving yourself an x equals a negative. Whenever you see that fraction there, and it's cool if you understand why that works that way, because if we're multiplying something a negative number of times, we're really dividing it. If we start with 1 and we divide it by 8 so many times, we're going to end up with a 64th or a 16th or something even smaller than that. So once we have this negative sign here, we can ignore this now. We've taken care of the fraction part of this, and now we just ask ourselves, how many times we multiply 8 by itself to give us 64? Right, it's twice, right?
That's 8 times.
Yes.
So 1.
And really, if we were to plug in 8 to the 2nd power, it would give us 8 to the 2nd power would give us 64, right? Because that's just saying multiply this by itself twice 8, or multiply 8 by itself twice. But since this gets flipped over, remember, flipping something over was how we got rid of a negative sign? And so since this is flipped over, it has that negative in front of it. So that's why we started with the negative sign. I'm going to try to erase that so you know what was going on out there. But we found our answer. So x equals -2. So one of two things are going to happen. You're going to be dealing with a nice whole number, in which case, maybe use your calculator. Try things out. Try 5 to the something power. Yeah, 5 to the 5th. Something is going to give you, or you could just try typing 5 times 5 times 5 and keep track of how many times you do that. However many times you multiply 5 by itself to get this number is going to be your answer. When you start seeing these fractions here, what kind of answer are you going to have?
Oh, wait, wrong thing.
You're going to have a negative answer, right? That's the only difference. This is second warning, okay? Next time, So I'll give you guys some time to knock out those 4. You've got answers to 3 and 5 on the back of your worksheet. So you can check your answers as you go. All right, so part 2. Our first step is the same as the first step in part 1. We're going to ignore the fact that there's more than just an x up here at first. Imagine there's just an x up there. How many times would you multiply 4 by itself to give you 64? Right, 4 times 4 is 16, and then a third time, 16 times 4 should get you up to 64. So let's go ahead and write that off to the side. 4 to the third power, 4 times itself 3 times, equals 64. This is a true statement. If we could just have this be 3, this would be a true statement as well, right? So what we're going to do is we're going to set everything in those parentheses. We're going to set this equal to 3. If all of this is equal to 3, then that should be a true statement over here, right? So underneath, go ahead and write x minus 4 equals 3. You guys already solved the root part of it. You found the root. The root of this power was 3. You already found that. So we're done with our powers and our radicals. We're now looking at simple things like addition or subtraction. The very last step, it says, get the variable by itself. Isolate the variable. How would you get this x all by itself?
Add 4 to both sides.
It's got a negative 4 being subtracted from it. So go ahead and add 4. Negative 4 plus 4 is 0. Keep it equal. Add 4 to the other side. This is the kind of stuff you guys were working on beginning of the school year. Getting the variables by itself. You guys should be very familiar with how to do this. What is 3 plus 4? It might say 8 on the back. I put the wrong answer, but some of you guys maybe has the right answer on the back for this one. It should say 7. Let's go ahead and take a look at number 2. Like I said, ignore this part. Just think to yourself, what times this base would give you your answer? How many times we multiply? Exactly, we multiply it by itself 2 times. And so let's go ahead and rewrite it as 9 to the what power? Second power equals 81. Once we have that, these are the only 2 key things. We're not worried about 9 or 81 anymore. We don't have to deal with any of that. We're going to set those 2 things equal to each other. Because we want this to be equal to 2. That would make it 9 to the second power equals 81. That would make it a true statement. So x plus 6 equals 2. And how do we get rid of that plus 6? It's positive. Take it away. Keep it equal. Take it away from the other side. What's our x value equal to? Oops. X equals -4. Since they're different signs, one positive, one negative, we subtract them. 6 minus 2 is 4. And we give our answer the sign of the larger number. We took away more than we added, so our answer is negative. Go ahead and take a look at 3 and 4. And you're welcome to take a look at the backside of the equation, of the worksheet. But we're going to be starting on that backside pretty quickly here. So I threw you an easy one for this. How many times would you multiply 7 by itself to give you 7? So we know that our number in parentheses here has got to be equal to 1. That whole parentheses. But if you write it out, show your work, it's easier to keep track of what you're doing. I'll go ahead and take a look at part 3. Part 3 starts off with opposite operations. We've already been doing that at the very end. Now we're going to put that at the very beginning, using our opposites to cancel out things that are next to the variable. Except for, what is it telling us to isolate on the instruction for part 3? Right, we need to get the power by itself. It says isolate the power. And so this whole thing, we need to get by itself. Order of operations would tell us deal with what's in parentheses first, right? We're doing an opposite order of operations. Since we already have the answer, we're going backwards from that. And we're doing addition, subtraction before anything else. So that's a little hint as to how we get rid of the 22 here. How would we get rid of that negative 22? Yep, opposite operation, keep it equal, add it to the other side as well. And now let's go ahead and rewrite our power. 2 to the x minus 4 power. That minus 22 is gone, so the equal sign is right behind it. And now what is it equal to? 64. So the 2's add together to give us 4. The 40 and the 20 add together to give us 60. And now it looks like what we were dealing with on the front side, right? I told you guys to just pretend like this is just one big X here, and we're going to find out how many times we multiply 2 times itself to give you 64. You can either just start typing 2 into your calculator, 2 times 2 times 2 times 2, or you can type 2 and then that caret top, and then how many times would you guess?
6 times.
So did you try it out? 2 to the 6th power? And it works, right? So let's go ahead and write that off to the side. We know if we have 2 raised to some power to give us 64, that it has to be raised to the 6th power. And I'm thinking you guys can take it from here, on this one anyways. What do you do with that 6 that you just found? Set these two guys equal to each other, right? And you guys have done those opposite operations to where it's pretty well ingrained in your brain. How we cancel, and then 6 plus 4 gave us. So if we were to plug in 10, we should be able to get a true statement. 10 minus 4 is 6. 6 to the 2nd power is 64. 64 take away 22 should give you 42. Let's take a look at this one. What are we going to try to isolate on number 2?
5.
Both of those, exactly. We're getting this by itself. What are the 2 things that we need to get rid of to get it by itself? The 125 and 8. Which one should we get rid of first? Right, that one is being added, so we do our opposite order of operations. Take it away. Let's go ahead and recopy our 125 times 5 to the x power. Our plus 8 is gone, so just write equals 1. Since we took away 8 from both sides, 9 minus 8 left us with 1 over here. We got rid of the 8, which means now we got to get rid of this 125. How might we do that? It's being multiplied, so the opposite of multiplication is division. Just multiply this side of the equation, that whole side. Give yourself a division bar, divide this whole side by 125. That gives us something divided by itself. Anything divided by itself is 1. 1 times 5x is just 5x, so that'll be by itself. Keep it equal. Divide this whole side by the same thing. It looks like our exponent is going to be negative. Our answer is going to be negative, which is, yes, going to end up be our exponent. So I'm going to write it out one more time. You might be able to just take a look at it from here, but writing it out will make it maybe a little bit more clear and make it look a lot like one of the problems on the front. So once you've identified that it's going to be negative, go ahead and give yourself an x equals a negative. Don't forget that negative. Once you've got that, ignore the fact that this is on the bottom here. And ask yourself how many times you're going to multiply 5 by itself to give you 125.
5.
Not 5 times.
It's negative 3.
So, yeah, on the front side, I think we did have very close to this. You asked yourself, how many times we can multiply 5 by itself to give us 125? And on the front, that was
3 times 3.
And these ones, the even numbers, you guys don't have the answers to, but you can check these by then plugging the numbers back in. We would have, that would be some ugly math when it deals with the negative sign. I don't think you're going to have negatives for your other even numbers. So you'll have better luck. It'll be more like this one, where when you find an answer, you'll raise 2 to that answer, then add 8, and if you get 40, you'll know you did it right. So I'll let you guys go ahead and finish up these last 5 problems. Once you got these done, I would recommend that you